Welcome to the second introductory tutorial for Excel spreadsheet. My name is Professor Michael D. Robertus, Department of Physics and Astronomy at York University. Okay, this is where we left off last time. Now I could have generated another file or opened up a new file for this particular tutorial, but I'm choosing rather to create and open up another worksheet. And you can have multiple worksheets contained in a single file, and that's what I choose to do here. So we click on the plus sign and we get a sheet name, which I'm going to right click, rename tutorial 2. So in this particular worksheet, I'd like to define a function, let's say a quadratic, and xy pairs. I'm going to give the independent variables with step size and then calculate the function, and then illustrate or visualize that particular function and show just some simple parameters and how to make your chart or your graph or your plot a little bit nicer, since Excel by no means generates publication quality plots at the outset. So before I go any further, I'd simply like to type in a character string what equation or the value of the polynomial. So I'd like it to be y equals, let's say, a1 times x minus 1 squared plus a2, where a1 and a2 are in fact constants. Now this is, again, not a function call. This is simply a character string, just to make it a little easier as I proceed through this tutorial. So I'd like the independent variables to begin with 0. Let's first of all label that will be the x column and this will be the y column. I'd like x to start at 0. Then I'd like to go in 0.1 increments all the way to 2.5. Now how best to do that? One could type now 0.1, character return 0.2, dot dot dot, all the way to 2.5. A bit clumsy. A better way to do it is to go back to the initial value, then come over to the fill option here, click on the fill option, and then series. Now we have a way of generating 100,000 x values if you'd like, or a million. I'd like the step size here to be 0.1, I think we said, and the stopping value to be 2.5. I'd like the data to go down the A column, so certainly along columns, and hit OK. And we see, I think Excel has certainly done what we've asked of it. Now I have to calculate the dependent variable y, but notice y contains two constants, a1 and a2. They're not defined. So I'd like to define them here. So I'd like a1, and this is just a character string indicating that I'm going to put a1 here. I'm going to put a1 and how about 0.5? And now a2, how about a2 to be minus 0.75, for example. Okay, now I'm left with having to define this function in B5, the first step here. And again, it's a mathematical operation. Equals must always preface it. Now A1 is 0.5, or at E2, but I must absolutely reference this. It's not a relative reference, it's an absolute, since every single calculation all the way down B column is in fact going to use 0.5 for A1. To do that, you type $E, $2. You see it highlights E2. And I must multiply that by x minus 1. Well, x is simply the cell value in A5, so that's A5 minus 1. And I want to square that and add A2, which has to be referenced absolutely again, $E, $3, return. And I end up with this particular value, and I should calculate to make sure that in fact it's correct, which it is. Now I need to enter this equation or calculation for every single one of the B column values all the way down. One way to do this is to cut and paste. Many ways of doing this, but the simplest way, most straightforward way, is to click on where the in fact equation has been defined, and then double click on the bottom right hand corner of that cell and it will fill in all the y values all the way to the last x value, so long as there's no space. If there's a space, it will halt at the space, essentially. So very simple technique. Again, one could worry about alignment here, centering, left or right justifying. You can also worry about setting the number of decimal places, etc. I leave that to the student. So now let's, in fact, plot these data. So what one does in a plot, of course, is one highlights, left mouse click, drag over here all the way down, highlight the data. Then, as you recall from the first tutorial, the Insert tab has the plotting or visualization options. I recommend, as before, the recommended charts. And that shows you the various options. Again, I think for us at the moment, this is a good option. So I hit OK, and I see that the chart has come up. I'd like the chart a little bit higher, so one can click on the chart and drag it up, and when the cursor gets to about this line here, the chart will move up to the top as far as you want, or you can move it down, left or right, and you can, of course, resize, as we've seen before. So now one sees that one has no axis labels, and the x-axis is sitting in the middle of a plot, a typical Excel phenomenon, it seems to me. So how do we remedy these things and make maybe the colors a little nicer, that kind of thing? So the three buttons here, the top button, very useful, click on it, and these are the elements with the check marks that are active. X titles are not active. I want them active. So now we have an X and Y axis title option. Right now it's expecting a Y axis title, and I'm just going to very creatively say Y axis and click on the X axis title, and I'll say. So now let's take a look what else we need. Well, you can play around with the data labels, error bars, etc., and legends. Particularly if you have two functions, which we'll see in a later tutorial. But I think perhaps more useful is the following. Let's say I'd like to change this particular, the x-axis label here to the bottom of the plot, or the top of the plot, wherever. Or I might want to change the y-axis, that kind of thing. So if you click on one of the y-axis labels in this case, then right-click, you see there are a number of options. Format axis is the most powerful and the most comprehensive. So this shows you, for example, that the y-axis minimum is -1, as you see, and the maximum is 0.6, as you see. Well, if I'd like the minimum to be, how about -0.8, and I'd like the maximum to be, how about 0.5, then it automatically resets this. It then sets the horizontal lines to be in increments of 0.2. That's probably fine. If I go down, if you had logarithmic scales, you can work with this. If you want to add tick marks, you can work with this. If you want to add labels, this is how you handle changing the labels. For the moment, what are the options? The options are next to axis, high, low, or none. So none is pretty obvious. There goes the y-axis labels. Next to axis is perfectly fine for the y-axis. However, for the x-axis, I do not like them in the middle of the chart. So for the x-axis, I've double-clicked, so now you see they're highlighted. If I have the minimum maximum between 0 and 3. Maybe I'd just like 2.5 here, for example, and it automatically adjusts. And I can change the number here and the label positions as well. But the label positions is the most helpful here. I'd like it low, and if when I click low, it takes it from the 0 point and puts it at the bottom of the x-axis, which is more typical for a plot. I can then also hover over a data point and right-click, and I can change, for example, the fill in the actual points themselves, which let's say I want to be red, and in the outline, the line joining it, I might want orange. Well, that's not, contrast is not so good. How about blue? And then one can deal with the size of the points, and the weight of the lines, all kinds of other things. So this is how one can do a little bit nicer chart, and one can change the size of the fonts, etc. And one can, of course, add a chart. So one can change the title of the chart, etc. So that shows how one can generate a reasonably looking plot for a function that you generate. We're going to show a little bit more complicated situation in the next tutorial, so stay tuned for that.